Welcome to the second video in my quadcopter build series. In this video I will be focusing mainly on the programming of the flight controller, and let's check how best it works. So let's go to the computer and see about the programming. So in order to program this SP Rising F3 flight controller, you will need the cleanflight configurator, and I will show you how to get it. So just go to Google Chrome and go to Chrome Web Store and search for cleanflight configurator here. You will see cleanflight configurator, and here it comes. So if you just click add to Chrome, and it will come as an app in your Chrome apps. So I have already installed it. So you want to hit on the app and a page will open up. So firstly, before, no need for welcome is just introduction, install all the drivers. So how to install this, you can see here latest CP210X drivers, STM USB VCP drivers, SADIC drivers. Click here and you will automatically go to the page where you will have to install the drivers. Install all the drivers and install it for Windows or Linux or any operating system that you have. Just install the zip file and extract it, then you will get all the drivers. So install all the drivers, then only the flight controller will get successfully connected to your to cleanflight. So in documentation and support, no need for caring. Then go to firmware flasher. Always flash the firmware. So select the right board. There are many flight controllers supported by cleanflight. Ours is SP Rising F3, and choose the latest firmware. Then you should connect the flight controller to the computer. So you will need this micro USB cable for connecting the flight controller to computer. So you can take most of the mobile chargers also come with this micro USB cable. You can use that also. So connect it in the USB port in the flight controller and then to the computer. And then you can see lights flashing on the flight controller, one red light and blue light. The blue light shows that the power is entering in the flight controller, and red light shows the status light. So then you select these two and click on load firmware online, and after some time in this page you will get the firmware. Now it is loading. The firmware will be loaded, and now you can see the flash firmware tab is coming in. Just flash the firmware, you will see it will flash it and just recheck it. So then you will get the latest firmware, and then after that you should hit select the correct COM port. Here I have only one COM port, no need for changing the baud rate, the same, and hit on this connect button. Then you will see that this tab, this picture is coming up, and so many icons are there on the left side, and you can see this tab is coming up. So this is a virtual image of your quadcopter, and if you move your quadcopter, this image will also move in that direction. Just check that. And it shows that your gyros and accelerometers are all working. If at any case this does not get connected correctly, then recheck your USB connection. If you hit connect, this page don't come out, then recheck your USB connection, or you might not have installed the drivers properly. Just check it. Then go to ports. For clicking any other UARTs, just keep it like this. Now if you are adding GPS and all, you should use another UARTs and all. There are 3 UARTs in the SP Rising F3 controller. So configuration, this is the main tab in which all the configuration for your quadcopter is done. So select the model there are fixed wing, tricopter, hexacopter, octocopter, everything in this. So select the, I am using, you can use quad plus and quad x. Quad x 1 2 3 4 means the motors will be arranged in such a manner 1 2 3 4. I am putting it as quad x, and connect the ESC spins correctly as 1 2, and there is an arrow in the flight controller that should point towards the, as the figure shows, it should point towards the side of 4 and 2. So connect the pins of the ESCs the same as this. Do not change it, otherwise you won't be getting the correct output. Then the next thing is ESC or motor features. This is the protocol that ESC or motor uses. So PWM, it's for the basic ESC 1 shot 125. So my ESC supports all of these 1 shot 125, 1 shot 42, multi-shot. This brushed is for brushed ESCs, don't use that. D shot 150, D shot 300. So there are D shot 600, 1200 and Pro shot 1000. So I am putting it in the best that my ESC have, that's D shot 300. So if you make any changes, then just click save and reboot. Then you will have this device rebooting and ready. Then the changes will be burned into your flight controller. So motor PWM speed separated from PID speed, no, don't do anything in that. So motor stop tab, at first it will be disabled. This disabled means once you arm the board, the motor will start spinning. So I don't like that, so I am enabling it so that it doesn't spin while arming, and when I push the throttle only it spins. So always enable disarm motors regardless of throttle value. That's used when you are arming by aux channel. I always like to arm by aux channel, so enable it. So these all values are, keep it as the same. No need for doing anything in the board and sensor alignment. No need for 3D, that's for reversible ESCs. If you are using it, then you should use the bidirectional mode in the BLHeli suite. No need for accelerometer trim. So this, then system configuration, this is the configuration of the between the ESC and the gyro. This 32 kHz is for the, here if you go to this question mark you can see that it is not suitable for such ESCs, it is for high grade ESCs. So in D shot it is for, keep it as 4 kHz gyro update frequency, and PID loop frequency also is 4 kHz. If you go to 8 kHz and save and reboot, then when it comes back you can see at this bottom CPU load is becoming 100%. That means your flight controller won't arm and nothing will work. So keep it as 4 kHz itself. And it's rebooting, and when it's come back it's just 32%. So I don't have a barometer and magnetometer, so no need for that. Then you can put the name for your drone over here, that's just your wish. And in this other features, if soft serial is for using the S-bus and satellite receiver, sonar means you can put it in the PWM mode. In the PPM or other modes only you can put sonar. Telemetry, if you have the telemetry module then you can enable it. I don't have all of those, I haven't used it. OSD, ESC sensor, that's only for KISS ESCs, don't use that. And I have added LED strip, so I have enabled it. Then the camera, I haven't added the camera. So choose the correct receiver, PPM, serial S-bus, PWM or MSP. So choose that PWM RX, save and reboot. So I don't have GPS, so don't select it. So that's what you should do in the motors tab. Then go to power and battery. In power and battery you can set the minimum cell voltage of each cell of your LiPo battery. So I have set it to 3.1. Don't keep it below 3 because if it goes below 3, then your LiPo, there are chances that your LiPo battery will be damaged. Maximum cell voltage is 4.3 and warning cell voltage is 3.5. Warning means that when it goes down to 3.5, then the beeper will beep, and if you are using LED strip configuration, then the lights in the LED will also flash that your cell voltage is below 3.5. So you can understand that your battery is low and you can go and charge it. So that's on the power and battery. Save and reboot. Fail safe, nothing to do with fail safe. PID tuning. So PID tuning is mainly done when it is not for auto leveling. So if you are if you are doing this for the first time, no need for caring about PID settings, because we are using auto leveling. That's the flight controller will level itself automatically, so no need for PID settings. If you are not using auto leveling, then you should check each movement and change the values in the PID settings. So at first it will come with 0.7, 0.7, super rate will be 0.7, 0.7, 0.7. Just change that to 0.8 so that it will be 1000 degrees per second. And then go to the receiver. In the receiver tab, what you should see is, you should switch on your multi-rotor, switch on your transmitter, and when you move the stick like in the T6 config, you should see the axis moving here also. So if anything is inverted in this, then you should reverse it in the go to T6 config, reverse it. And the main thing that you should do, if you keep the sticks centered, then it should be at about 1500. See, I have for me everything is about 1500. Just check about that. This is the aux channel, so just check about that. And if it is not about 1500, as I have told you, I have used a subtrim tab in that. Subtrim in the T6 config. Go to the subtrim, change the values, increase or decrease the values, and simultaneously see it at this cleanflight tab, and make sure that it is around 1500 microseconds. That's all you have to do. So now the next tab is, nothing else should be configured in it. In this, everything is same. Go to modes. This is the place where you should put the things that you are adding. So at first it won't be having anything. You should click add range. I have already put one, add range, and then you can drag and keep the places, the microsecond of the receiver where your code will be out. For me it is aux1 channel, and those are the, for the FSCT6P, those are the potentiometer like things on the top. Add the microseconds by looking at the receiver tab, add the required microseconds over here, add range. Angle mode, the angle mode is the mode that I have told you, it's for auto leveling. So once if it is in the angle mode, the quadcopter will level itself, so always put that also. That's also I have used it as aux1. So save these settings, and then I have used beeper buzzer, that also I have used in aux1 and the same length, so the buzzer will also start working over there. So if you don't need this, then just close it. You can put other modes also. And adjustments, there's nothing to do with adjustment. Servos, we are not using any servos. GPS is also not there. So in the motors tab, actually we should need this motors tab for configuring it. In the one shot modes and all, you should need this motor tab, because you should keep the throttle high, then connect the power, then put it down in the one shot mode. Since we are using D shot, there is no need for the motors tab also. So OSD we are not using it. Race transponder and LED strip. So LED strip, at first there will be this SP Racing F3 flight controller can support 32 LEDs. So the select wire ordering mode, and see your craft is like this. This is the front of your craft. and this is the back, this is the left, this is the right, and this is the left. So arrange the LEDs in such a way. Here I have a 5 LED in one strip, so I have here 0, select it, 0, 1, 2, 3, 4, just select it, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. If you select, go to function, if it is none, then you can add colors. You can add colors like this. Click click on this, save, and you will get colors on it. If you want to use it as battery, then click hit the battery. This is what I told. If the voltage goes below 3.5, then this will show an alarm. It is an indicator. Then modes and orientation, that's used for that. If you enable roll, then if you move the roll stick, it will blink. You can use it for pitch, yaw, throttle, auxiliary, everything. Then the next is arm state. Arm state is used for telling whether your drone is armed or not. So GPS, RSSI and ring and all we are not using. So after doing all that, save. And sensors. In the sensors tab, you will get the graph of your gyroscope and accelerometer. If you move the drone, you will see the variations in the gyroscope and accelerometer. If you move it suddenly, then the graph will be more. That shows that all your sensors are working. Tether logging, nothing. Black box we haven't added. And in the CLA tab, this tab is used for putting external features like enabling servo outputs and all. You should use the CLA tab only. So this is all about programming cleanflight. Now let's go out and see whether it flies or not. Firstly, turn on your transmitter, make sure the throttle is low and it is disarmed, and connect your quad. You can see the lights. So the battery light is showing an yellow color, which means there is enough charge in the battery, and this light is for blinking, and this is showing green that it's disarmed. And when I am arming it, you can see it is turning blue, and if I move the sticks to the left, you see that it is moving. You can see the lights are coming. So let me test the flight.